All right, so today's notes are on the properties of exponential functions. Our content objective is to explore the properties of functions in the form y equals a times b to the x minus h plus k. And our language objective is to use transformation vocabulary to describe exponential equations and graphs. So before we delve into that, the first thing I want to do is review transformations because I'm guessing a lot of you have forgotten these. So transformations are the ways we can take a parent function, the simplest version of a function, and move them around to get all the other functions in that family. So we can take a simple function, apply all these things to it, so a, h, and k, and we can get a whole mess of other functions. So these transformations include translations, which are also sometimes called shifts. So translation, shifts, or slides, they all mean the same thing. You're moving it left or right or up and down. So you just take the shape and then move it in those directions. Those are, again, given by h and k here, and we're going to talk more about those in a minute. But h and k move them up and down or left and right. H being left and right, k being up and down. And these result, again, from adding or subtracting. So notice how h is subtracted, k is added. So adding and subtracting is what moves it up and down and left and right. Stretches and compressions make them steeper or flatter. So a stretch is if it's made steeper, or compression is when it's made flatter. And this is denoted by a, what you're multiplying or dividing by. So if a were a fraction, that would count as dividing, it'd be a compression. If a were a number greater than 1, that would be multiplying, that would be a stretch. So stretching is multiplying, dividing is compressions. The last thing is reflections. So reflections flip the graph over the x or y axis. So they just flip the whole thing this way or this way. And these, you get reflections when you make something negative or something in the function negative. So it flips over the x-axis if you make the a value in front negative. So that's a vertical reflection. So a vertical reflection is when you have a negative a value. You'd have a horizontal reflection if you made this little x and the exponent negative, so that would flip it over the y-axis, be a horizontal reflection. So I know that's a lot of information to try to review right now, but we're going to put it in the context specifically of exponential functions. So exponential functions, again, a tells you your stretch or compression, and if a is negative, then it also tells you that there's a vertical reflection. So if just a without the sign is greater than 1, it's a stretch. If a without the sign is less than 1, it's a compression. And then the sign tells you if there's a reflection or not. Again, same thing applies with x for horizontal reflections. If there's no negative, then it would not be reflected. If x is negative, then it would be horizontally reflected. The horizontal translation is denoted by h, so this tells you how many are moving left or right. Again, because the formula has a negative, it's always going to be in the opposite direction of as it appears in the equation. So if it was x minus 2, it moves 2 to the right. If it were x plus 2, it would move 2 to the left. K moves it up and down just as it appears. So if it's plus 2, it moves it up 2. If it's minus 5, it moves it down 5. But K tells you your vertical translation or how many you move up and down. So again, quick refresher of that vocabulary. Now let's review that with a quick check. So I'm going to flip the page for a quick check. I want you to pause this and try it on your own. I want you to identify the transformations made to the function y equals 2 to the x. So if this were your parent function, what transformations have been made to the function in the two equations I gave you here? So I just want you to identify them at this point in time. Pause it if you need to. I'm going to go over it now. So I'm just going to work my way from left to right. So the first thing I see here is I'm multiplying 3 times 2 to the x. So since I'm multiplying by 3, it's outside, it's going to be vertical, and it's greater, the absolute value is greater than 1, so it's going to be a vertical stretch by 3. Then I'm going to go 2 to the x was my parent function, so now I'm going into the exponent. Since I'm inside, in with the exponent, I know that's going to be horizontal. So anytime it's in with the x, so in with the x means horizontal, outside is with the y, so it's going to be a horizontal translation. And it's going to be 1 right. Because it's minus, I actually go the opposite direction, so it's 1 to the right. Then I keep going, I have a vertical translation and it's going to be up 4. So since it's plus 4, it's going to be up 4. So just for the sake of separating these two, the next one, I'm going to start, I have a negative, so I'm going to start by noting that I have a vertical reflection. So because my A is negative, I notice right away that I have a vertical reflection. And this time, since my A value, when I don't look at the sign, is between 0 and 1, I know it's going to be a vertical compression. By 1/2. So vertical compression by 1/2. And then I keep going 2 to the x, but now in the exponent, I know that it's horizontal. So because I have a value in with the exponent, it's going to be horizontal. Since it's plus 2, I'm going to go horizontal translation left 2. So again, I go the opposite direction. So since it was plus, I'm going to go to the left 2 since it's horizontal. And then last but not least, I have a vertical translation down 3. So vertical translation down 3 is that last one, and those are the transformations we've made to those functions. So that's it for transformations for the moment, but we're going to talk about, actually not yet. So the last thing I want to mention is the asymptotes that we talked about in our last lesson, the value the graph gets closer and closer to but never quite reaches, or the line it gets closer and closer to but never quite reaches, is always going to be y equals k. So when I say k, I mean the number added or subtracted to the end of your exponential equation. And so because I can say that the asymptote will always be y equals k, I know the range will always be y is greater than k or y is less than k, depending if the graph is reflective or not. So again, your asymptote will tell you your range because it will always be y is greater than the asymptote or y is less than the asymptote, depending on which way the graph is going. All right, so that's it for reflection or for transformations for the moment. I will show you how you could use these transformations to sketch a function at the end of this if we have time, but for now I'm going to delve into a method that I think more people will find helpful. So for our last example, I want us to graph the equation y equals 2 to the x minus 4 plus 1. So the way we're going to do this is by making a table and then plotting our points and sketching the graph. So in order to make this table, I'm going to put my h value in the middle. So I just told you here, h in this problem is actually 4. So I'm going to put 4 right here in the middle. And I'm going to do 2 values before this, so 3, 2. And I'm going to do 2 values after this, 5, 6. So I've made my table by putting h in the middle, just like we did with our vertex in quadratic functions. But I'm going to put h in the middle. Now I'm going to plug in these x values and get my y values. I left space here in my table to show you how I completed this work because it can be a little bit less intuitive than some of our other ones. So I have 2 to the 2 minus 4 plus 1. 2 to the 2 minus 4 becomes 2 to the negative 2. So again, this is 2 to the negative 2 plus 1, which becomes 1 over 2 to the 2 plus 1. If you notice that, so again, this is why we did our rules of exponents earlier. So 2 to the negative 2 flips. If you can't read this, sorry, I'm trying to fit this in a small space. 2 to the negative 2 flips, it becomes 1 over 2 squared plus 1, which becomes 1 1/4, or 1.25. So 1 1/4 or 1.25. I'm going to do it at the next one with 3. So I have 2 to the 3 minus 4 plus 1, which becomes 2 to the negative 1 plus 1, which is 1 over 2 plus 1. So again, negative exponents lead to fractions. So maybe that will indicate to you why we're never going to get into the negatives or why we end up with asymptotes. But we'll talk more about that later. So I end up with 1/2 plus 1, which is 1.5. I'm going to keep going. So I have y equals 2 to the 4 minus 4 plus 1. 4 minus 4 is 2 to the 0 plus 1, which is 1 plus 1 or 2. So again, I'm just going to keep working through this. Now I'm in positive numbers, so it's getting a little bit easier. So I have 2 to the 1 plus 1, which is just 2 plus 1 or 3. And last but not least, I have 2 to the 6 minus 4 plus 1, which is 2 to the 2 plus 1, or 4 plus 1, 5. All right, so for all of these, all I did was plug in my x value to the exponent here and calculate it out, and then I'm plotting my points. So now I go to 2, and I have 1.25, so that's going to be about the quarter way of the through, so I'm quarter of the way through 1 to 2. 3 is going to be 1.5, so very slightly above that. 4 is going to be at 2. 5 is going to be at 3. And then 6 is going to be up here at 5. So you can see here, I'm not doing my best sketch. Again, wouldn't recommend you do this in pen, but this is what my graph ends up looking like, very roughly, for the exponential function. So that's all that you have to do for today. For those of you that want to see me graph a exponential function using transformations, I will do that next. But if you are good with that, you can stop taking notes at this point. You're all set for what you have to do for today. So I'm going to do one more method where I graph with transformations. If you want to do that, you can. If not, you can stop taking notes now. So again, I'm going to do another example where y equals 2 to the x minus 4 plus 1. So it's the same one. I'm just now going to apply my transformations here. So in my original function, I'm going to make a table. Sorry, I'll write my steps. So my first step is going to be to make a table for my parent function, which would be y equals 2 to the x. So I'll make my table x, y. This is for y equals 2 to the x. So I'm just going to do 0, 1, 2, negative 1, negative 2. So when I make that parent function, 2 to the negative 2 is 1 over 4. 2 to the negative 1 is 1 over 2. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. So again, all I did was make this table really quickly by plugging in my x values to my original parent function. Now I'm going to apply my transformation. So I'm going to make step 2, make a new table for the transformed. And the way I'm going to do that is by taking my transformations and applying them to x. So x minus 4, what that's really doing is adding 4 and moving it 4 to the right. So I'm going to do x plus 4 here. And I'm going to do y plus 1 here. And this is going to be for my new function. So all I'm going to do is take my original functions and then apply them here. So negative 2 plus 4 is 2. Negative 1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. 2 plus 4 is 6. So if you notice, now my x values match the x values from our table in the last problem. So they're actually the same thing. Now I'm going to do the same thing with y values. I'm just going to add 1. So I have 1.25, 1.5, 2, 3, 5. So I think this can be easier in a lot of ways because you're just applying your transformations to straightforward, simple numbers. That makes it somewhat easier. Then you're going to plot and sketch your new points. I'm actually going to skip this step for the sake of time because we did this in our last one. But again, all you're going to do is take your transformations. Since this moved forward to the right, you just added forward to each of your x's. Since this moved 1 up, you just added 1 to each of your y's, and you have a new set of coordinates that you can plot and graph, which match the same ones on our previous table. So that's it for today. Make sure you write down any questions, comments, or concerns you have so we can go over them together in class.